I got nothing.
Okay.
Professor?
Yes.
I have a question in regards to questions regarding polygons. Would it be like finding the area?
Well, it could be anything. If I give you anything about anything about area or perimeter or any of that sort. Yes. Could be, yeah. So yeah, I guess for our polygons, there's not many things I can ask you, but it either could be about the size or it could be about the area. Okay, yeah. So let's say, for example, one of the questions given in the past was this example: find the area of a regular octagon. Octagon is sides. The sides, let's say, how about 2 inches? And then another kind, and then another kind, how about, okay, and then another kind of a problem which I gave in the past was this. How about this? This was one of the past examples. Find the area of a dodecagon, of a regular dodecagon, a regular dodecagon, 12 sides, inscribed in a circle of radius r. So when it comes to geometry, of course, there are other kinds. I have given many kinds of problems, and these are the kind of problems which I think are kind of interesting, and yeah, and so on. So and both of these are, of course, yeah, and they are area problems. Okay, so and of course for both of these, without using a calculator, without calculators, without using calculators, and also without using any trig, without using any trig formulas. So let me say that. This one too. Without calculators and without trig. So, okay. So today is a test, and so you know what, these examples, the past. So I did not put these 2 problems on the test this time, but you might say something similar, or it could be a hexagon. A regular hex is a nice problem too. It's a little bit more basic. I think a regular octagon, a regular dodecagon is a little more interesting. Okay, so let's see. It's 8 o'clock already. Okay, let's begin. Okay, good morning, everyone. So here today we will have a test. So we will have a regular class meeting until 10:50, and then after our class is over, the test will be available or open at 11 a.m. and the test must finish by 10 p.m. So there is actually a 11-hour window, and the test, I think the time limit was 2.5 hours. So you should start the test by about 7:30 p.m. Let me write this down. Must start the test Must start the test. Must start the test before what? 7:30 p.m. Of course, if you start the test at 8 p.m., then is it 7:30 p.m. or is it 8:30 p.m.? Oh, it's 7:30 p.m. Because I want you to finish the test by 10 p.m. So before 7:30 p.m. Okay, so you know what? Although I'm giving you 2.5 hours, I think many of you will probably finish within 2 hours. You know, I don't think it's that long, but it's not, may not be that easy. So all of these problems, by the way, the kind of problems, in case I didn't tell you, these are the problems I like. The kind of problems I like are problems I like to put, instructor likes to put on the test are short, are what? Are difficult, how about short, and difficult, and handsome problems. Okay, so just want to remind you here. Okay, so I like these kind of problems. So let me say this: short. So what is short? Well, short means doesn't take that much time. I think in this class of one, I think the time limit is about 5 minutes. So if you are well prepared, you know what to do, then any of these problems should not take more than 5 minutes. That is, if you know what to do. Of course, if you don't know what to do, then of course, you're not going to solve the problem in about 30 minutes or even an hour. So that's what I mean by short. So I don't like just long problems. I hate those myself. So I'm not going to give that to you. Short. That's what I mean by short. So that's what I mean by short. And then difficult. Well, that is not that easy. I don't like to give you obvious problems, but problems which you have to think. So they're a little bit more involved. Okay. So it's either difficult. I would say difficult, or difficult looking. Sometimes I use this term, or difficult looking. They're not really difficult, but they look difficult. And of course, when the problem looks difficult, sometimes students think that they are difficult. So many times it's not really that difficult, but well, it depends how you look at it. If you don't know, then of course, I guess that is difficult. That's what I mean by difficult. Okay, not obvious. The simplest problems, I don't give it to you. But then you usually don't give you the hardest problem either. Oops. Let's start the test before it's in 7:30 p.m. Let me write that again. 7:30 p.m. Okay.
Question.
Yeah. And then let me just, yeah.
How many questions are on the test?
Well, on this test, I think there are, how many problems did I give you? Let me see. I just wrote the test yesterday, last night. There's 7 problems. 7 problems on this test. Usually, the number of questions on any test or any midterm will be about somewhere between 7 to 10 problems. That's usually the case. And sometimes a problem has many parts. So for example, like on this test, do you have many parts here? Actually, not many problems have many parts. But one of the question has like part A and part B. And so essentially, one of the questions has 2 parts. And the 2 parts are not really related, but they're similar kind. So I just put them under one question because one question is too short. So one question, if you do it correctly, it might take a minute. So that's not too, that's too short. So I gave 2 problems there. So one of the questions is actually 2 questions. Okay? And then I have 7 big questions. Usually, there are about 7 to 10 big questions. That will be the case for all the midterms. And for the final exam, usually it's a little bit longer. So I usually give somewhere around like 10 to maybe 12 or 13 problems. Somewhere between 10 and 13 problems, usually for the final exam. The final exam, and I'll give you about 3 hours. Yeah, on this test, I think I gave you 2.5 hours, but it's not really that long. to spend 2.5 hours. I'm giving you more time than what I think is necessary because it is the first test, midterm 0. So you'll have some time. But again, some of you might feel that you are still short of time. But again, if you're short of time, I think that is a real problem, okay? Because I think I am giving you enough time. And if you can't do the problem, then of course it doesn't matter how much time I give you. You're not going to do the problem, right? So assuming that you know how to do the problems, I don't think it takes that long. So 2 hours, if you can finish the test in 2 hours, I think that would be good. Okay? And then here, short, difficult, and handsome. And when I say handsome meaning I usually like to give you problems where the numbers are reasonably nice. I don't give you numbers which are so ugly. That I don't give you. Okay? So handsome means, okay, again, handsome. Let me see, handsome. Numbers are reasonable. Not so messy. That's what I mean by handsome. Basically, all my problems, even though calculus are allowed, the problems are designed in such a way that you don't need a calculator. So let me put it this way. Every problem, even though calculus is allowed, of course, calculus has a major downside. Again, I don't accept approximate decimals, so that's a no-no. So you should not use those calculators on many of those problems. But you can check your work using a calculator or graphing calculator. Okay, yes. And of course, the numbers when I give you, the problems are designed in such a way that you don't need a calculator. That's how I designed the problems. Again, all problems are designed in such a way that you don't need a calculator. And on this test, do you need a calculator? No. In fact, all of the problems on this test, you cannot use a calculator to do any problem. Again, on this problem, there is not a single problem here where you can use a calculator. Okay? So calculator is not that useful here on this test. So usually that's what I try to do. This is math. This is not a calculation. Calculation is the smallest part of math. It's the less important part of math. The big important part is the logical part. That's the hard part. Okay, so does anybody have any questions on any of these geometry problems here? Octagon or dodecagon or any of these? No? Okay, then I'll skip it then. Okay, so let me save this and I'll clear the drawings here. Okay, does anybody have any questions before we start? And by the way, today's plan is this. So today I'm planning to go over. Of course, if you have any questions, I will go over your questions. But besides that, I would like to go over let's see, study 07 11 through 07 I think 14. I would like to go over these. And by the way, I would like to start chapters math 7 notes starting with 07, but 0711 through 0714 are still pre-calculus. They're still pre-calculus. They're still not calculus yet. So let me just check my notes here. Is it correct? Math 7 11. Let me see. 11 14. Yeah, actually 13. Let me put 13 here. The 13. Yeah, but some of these sections are a little bit long. Okay, so that's what I have to go over. That's still pre-calculus. Officially, the calculus starts from section 1.4, I should say. Yeah. Well, that's what I would like to say is the starting of it's kind of questionable. 1.4, 1.5 is like a border. It could be considered as pre-calculus, or it could be considered as the beginning of calculus. Okay, but anyway, we'll see. Any questions here? Anybody have any questions?
So just to confirm, 0711 through 0713, these would be great to study for the midterm, correct?
Yeah, sure. So today I'm going to spend time here, and so these files here, I'm officially starting calculus here, but again, section 1.1 through about 1.3 or 1.4 are still pre-calculus. So when I go over these notes here, some of them would be a repetition, and so these are kind of covered on today's test too. So they're not new. Okay, they're not new because they are covered by pre-calculus. But that's what I'm going to go over, and then after this, I might start section 1.4. Okay, and as I said before, the next test, the chapter 1 test, once we finish chapter 1, then there will be midterm 1. Midterm 1 will cover everything up to chapter 1. So, and my plan is to give you the test on Wednesday next week. It's coming up very soon. Okay, that's what I like to do. All right? Okay, so any questions before I start section 0.0711?
I had a question about one of the problems on the test prep you gave us.
Okay, what is it?
It was number 11. Could you show me how you would solve that one?
One?
Example, sorry, let me pull it up. Yeah, it was number 11 on the M0 test prep.
Oh, M0 test prep example 11. Okay, I see that one. Okay, so let me how about this? Let me just erase. Oh, this one doesn't have anything, so let me just erase this. And so let me open up the file. Oh, this is M0 test prep example 11. Example 11 here.
Yes. Yes.
Okay, example 11. Okay, example 11. Okay, so this one. Let me see. Okay, example 11. Okay, I get it. So this one here, this one is actually a polynomial equation, and the polynomial equation, this one is actually solved by factoring by grouping. So what I'm going to do is let me open up a this is too little space here. So what I'll do is I'm going to open up the whiteboard, and then let me solve a problem there. So share screen. Let's get to the whiteboard. And let me do that problem right here. So this is the M0 test prep. So this is the M0, This is the M0 test prep, and this is example 11. Okay, example 11. So what is that? That's actually an equation. So it looks like there is no instruction here, but it should say, oh yeah, it does say solve. The solve. And then what we have is, we have this. We have 2x cubed. Okay, so let me write down 2x cubed. And then minus x squared. Then minus x squared. And then what? Minus 8x. 8x. And then what? Plus 4 to 0. So let me write that down. So basically this right here. I actually did one step here. Between the original equation and this, I have done one step. Okay, so I just did one step for you. So if you move everything to the left-hand side, well, that's 8x on the right side, and then add negative 8x to both sides, you get this right here. So this is the equation we get. So the equation we get is 2x cubed minus x squared minus 8x, and the plus 4 is equal to 0. Usually, for most equations, we want to let the right-hand side equal to 0. And then do something with the left-hand side. In this case, we want to factor the left-hand side. Usually that is the case, or that is the method. That's what we try to do, so that we can find the solution. So this is not in product form, so we want to factor this. So what is this? Now note that the left-hand side has 4 terms. So when you have 4 terms, what is a good method to try? Good factoring method to try? 4 terms. First of all, any monomial factors here? So we look at this guy. Any monomial factors? Monomial factors. So the polynomial which I marked in red, does that polynomial have any monomial factors? Like monomial factors meaning like a common factor. Like sometimes they call it GCF factor, greatest common factor. Any monomial factors here? No, we don't have any. Means the greatest common factor is actually equal to 1. So when the greatest common factor is actually equal to 1, we say that there is no common factor. So between 2x cubed and then x squared and then 8x and 4, there is no common factor. So a factor which is common to all 4 terms, that is factor to all 4, a factor common to all 4 terms, and then we don't have any. Do you have any? No, we don't. In this case, the answer is no. And there, no means the greatest common factor is actually 1. So it's not that there's no common factor, but the common factor is 1, and therefore no need to factor. So no need to factor 1, it doesn't change anything. So in this case, we have no common factor. Then the next thing we want to try is this. Now factoring, then factoring of polynomials with 4 terms. Now, this is 4 terms, not 4th degree, okay? Watch out here. This is 4 terms, not degree 4. Degree 4 is not the same. Here on the left side, the polynomial we have on the left side of the equation is 4 terms, but it's actually a cubic polynomial. It's degree 3. And by the way, the degrees do not get added. The degree of every term has a degree, and then the highest degree of the term, of any term, becomes the degree of the entire polynomial. So in this case, the left-hand side, the polynomial which I marked in red, that polynomial has 4 terms, and the degree is 3. It is a cubic polynomial. Now in this case, then for factoring 4, then for factoring a polynomial of 4 terms, what do you apply? Try group factoring. That's what we tried. And we say this is actually 2 and 2. 2 and 2, 2 and 2. 2 and 2 group factoring. This is usually the factoring of the group factoring you learn in intermediate algebra class. And there's also a 3 plus 1, but in this case it's 2 and 2 grouping. Okay, so now to get into the problem here. So what I'll do is this. So in that case, what do you mean by group factoring? The 2 and 2 group factoring is this. Look at the first 2 terms and the last 2 terms. So let me put this in bold here. So how about this? I'm going to put this in bold. The first 2 terms and the last 2 terms, we are going to factor them separately. A factor monomial for the first 2 terms and the last 2 terms separately. So if we do that, then this is what we get. So we will get this. We get, for the first 2 terms, we get x squared, and then that will be, you know what, let me, how about this? Let me just type this in. I think typing my will look much nicer. So let me just type this in. So we'll be factoring x squared, and so we get x squared, so we get 2x, and then we get minus 1, and then minus here, yes, minus 4 times, and then this 2x, and then minus 1, and then we actually get 0 right there. And so all I need to put is put a square there. You get this. So the first 2 terms is 2x cubed minus x squared. So we apply monomial factoring. And so that will be x squared times 2x minus 1. So we apply monomial factoring only to the first 2 terms. And then plus, and then we apply monomial factoring in the last 2 terms. Except in this case, when you factor the 2 terms at the end, note that the highest degree has a minus sign. When the highest degree has a minus sign, what do? We actually factor out the minus sign. So the rule for factoring a minus sign is this. You factor the minus sign when the highest degree term has a minus sign, not when everybody has a minus. So once again, the rule for factoring is different. The rule for factoring the minus sign is if the highest degree term has a minus sign, that's what I call the leading term. When the leading term has a minus sign, then we factor out the minus sign. So when you look at the last 2 terms, we have minus 8x and the plus 4. The highest degree term is minus 8x. So we factor the minus, and then 4, and then when you do that, you get this. And so now you can now see what's going on. And now you can factor, monomial factor again. So now we get this, x squared. So what you get is x squared, the minus 4. And the common factor is going to be 2x minus 1. So let me write 2x minus 1 first. And then times this is equal to 0. And so we get this, and of course I need to put a square there. Okay? And let me just erase this arrow here. Oh, not that, this arrow. But you know what? I cannot erase the arrow. What happened here? There we go. Good. So now, now we have 2x minus 1 is linear, so that factor is done. But the other guy is not done yet. So we have now what? We have 2x minus 1, and then times x squared minus 4. That's a binomial. So we apply special factoring. Special factoring difference of squares for this one. So x minus 2, and then times x plus 2. So I think this part I did not really mention, but factoring is a very basic, skill you have to master. So we get this, and now from here we can now make the conclusion. So the conclusion is that it's applying the zero property. 2x minus 1 equal to 0, or x minus 2 is equal to 0, or x plus 2 is equal to 0. Now if you want to, you can skip the step. This step is not really required because you can now go to next one. So the answer is x is equal to half, or x is equal to 2, or x is equal to x is equal to minus 2. And so this is now the final answer. Let me just write the fraction there. I would like to write the fraction in this form rather than the slash, using the slash. So x equals half, or x equals 2, or x equals negative 2. So that will wrap up the problem, and there is the final answer right there. And if you box that, that's good. But you don't have to. But anyway, that's the final answer. Any questions here?
Can we leave the answers as like x plus 2 equals 0, or it has to be x equals?
Yeah, you have to solve x. You have to find x equals, because it says, now this one, the instruction says solve. So whenever it says solve, what does that mean? So when it says solve, and then solve, so when you have a solve, and then you have an equation, then the final answer should be what? Should be what? Therefore, x is equal to blah blah blah, and then dot dot dot, or something, or in this case, or x is equal to blah blah blah. So this is required. So you cannot leave x minus 2 equals 0, x plus 2 equals 0. No, that's that. Now, if I ask you to factor this, then the format will be different. So let's say example. Let's say how about example? Let's say example very similar. Let me call this guy example B. And this one it says how about this? Factor f of x, and then I will write f of x is equal to, or factor this. You know what? Maybe I'll just write this here. I write factor x cubed minus x 2x cubed, and then minus x squared, and then minus 8x, and then what? Plus 4. So if I give you a problem like this, and so this one is essentially the same problem, but written differently. If I give you a problem like this, factor 2x cubed minus x squared minus 8x plus 4, then the work is essentially the same. But now in this case, how do you format? In this case, what you do is, in this case, a solution. You have this. We have 2x cubed, or you can actually name it. Okay, so we can say 2x, and then cube, and then what? 2x cubed minus x squared, and then minus 8x, and minus 8x, and then plus 4. So you would actually start with this. So this will be what? Minus 2x cubed, and then minus x squared, and then this part right here, the middle part will be exactly the same. And then at the end, though, the bottom line will be this. The bottom line will be, in this case, 2x minus 1, and then times x minus 2, and then times x plus 2. In this case, if you write this, let's say this, x is equal to, and then blah, 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 like this, then in this case, that will be wrong. So let me put it that way. So here, this, so that will be wrong. So the final answer will be this. If I ask you to factor this, then this would be the final answer. So if you give me x equals something, that will be wrong. Okay? Because that's not what the question is. The question is to factor this polynomial. Factoring means writing that polynomial as a product of what we call prime factors. The product of prime factors, and these guys right here, they are prime factors. They are prime factors. They're not prime numbers, but they are prime factors because they are like a prime. For numbers, they're like a prime. So we call them prime factors. Prime numbers are numbers which cannot be written as a product of two smaller numbers, except by one. And these expressions, they cannot be written as a product of smaller factors, and therefore they're called prime factors. So writing a polynomial as a product of prime factors, that's what we call factoring. Factor. So factor, you do this. And also, this is what I call an expression-based problem. This is an expression. This is an expression. Expression. Now, this right here is an equation. A different format.
Have you heard about these camps in Australia?
Is
is it right? Is it wrong? What's going on in Australia?
So what is the difference between equation and equation? Well, when you look at my solution here, there's a comparison. When you have an expression-based problem, then on the left-hand side, I put equal sign like this, because they're equal. And then dot, 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 then equal at the end. And this. But when you have an equation here, then on the left-hand side, you know what, I don't know whether you have noticed it, but I don't put equal sign, I put the arrow sign. But that's what you have to put, because it means it implies. Again, I can explain the difference between these two here, but again, it implies this, okay? So, I don't know, should I explain this? Should I explain the difference between the arrow sign and the equal sign? So let me give you an example here. So let's say if I do, let's say, how about this? Let's say solve, let's say example. Let me give you a very simple problem. Let's say example, solve, and then I say this, solve, and then let's say 2x is equal to, let's say, 10. Okay, then how do you solve 2x equals 10? Of course, this one everybody knows the answer. In this case, the solution is this. Solution is 2x. 2x is equal to 10. And then on the left-hand side, we are now going to put the arrow. I'm going to put the arrow here. And the arrow is that we are going to multiply by half to both sides. So if you do that, so you know what, okay, maybe I'll just write this step. All right, you know what, this is, I'll try to explain this here. 2x, and then times half is equal to, and then 10, and then times half. So in this, what we do is, we multiply both sides by half. So now I'm trying to explain this arrow sign, okay? So I'm trying to explain this arrow sign. So what I'm trying to say is this. So when we have an equation which says 2x equals half, 2x equals 10, then what I'm saying is this, if 2x equals 10, then what is true is we can multiply the left-hand side and right-hand both by half. And so I'm saying that if 2x equals 10, then 2x times half must equal 10 times half. But note that is 10 equal to 10 times half? The question is 10 equal to 10 times half? No. 10 is not equal to 10 times half. Again, 10 is not equal to 10 times half. They're not equal. So if you write equal sign here, that will be a mistake. Again, 10 is not equal to 10 times half. And 2x is not equal to 2x times half. They're not the same. So 10 is not 10 times half, and 2x is not the same as 2x times half. Basically, if you now solve this, what do you get? Our final answer will become x equals 5. So if you look at this here, if you look at this equation here, note that 2x equals 10. What this arrow means this: if 2x equals 10, so let's say 2 times something is 10, then that something must be 5. That's what this means. But 2x is not x, and 10 is not 5. So you cannot put the equals on here. So what this arrow sign really means is, let me now explain to you what this arrow sign means. This means what this really means is if a 2x equals 10, then x equals 5. That's what it means. But note that 10 is not 5, and 2x is not 10. 2x is not x. So that arrow means if the first one is true, then the second one is true. So in this case, we use the arrow sign, not the equal sign. So whereas if you have another question like this example, how about this example? Let's say we have 2 times. Let's say 2 times 3x, and then what, minus 1, and then plus, and then let's say x. Now how do you simplify this? Now in this case, the instruction way will say simplify. We'll say simplify this. In this case, what is it equal to? The solution? Well, it's going to be 2 times what? 3x is what? 2 times 3x. 3x minus 1. So let me just finish this. 3x minus 1, and then plus x. What is that equal to? That is actually equal to, this is 6x, and then what? Minus 2, and then plus x. What is that equal to? That is equal to 5x, and then minus 2. Note that in this case, this is what I call an expression-based problem. We have an expression, there's no equal sign. And therefore, in this case, we actually put the equal sign. Here, as opposed to the arrow sign. I don't know. Do you understand the difference here? And by the way, many of you still do not understand the equal sign, the arrow sign, because when I grade your quiz, quiz 1 and quiz 2, some of you put the arrow sign when you have to really put the equal sign, and some of you have to put the equal sign, but then you put the arrow sign, and many of you didn't put any sign, which is also incorrect too. No sign is also incorrect. When you write no sign, that means they're not related. So if I, let's say, write example, let me write over here. So example. So let's say if I write, let's say, how about example, let me write, let's say, for example, let's say 11, and then plus 5. And then write, and then let's say, how about let's say 36, and then I write, let's say, how about 12 plus, let's say, 22. Is that correct? Is that correct or incorrect? Example, 11 plus 5, and then I wrote 36, and then I wrote 12 plus 22. Is that correct or incorrect?
Incorrect.
No, that is still correct. You know why? Because it says 11 plus 5, and then it's 36. So did I tell you that 11 plus 5 is equal to 36? Did I say that? Did I write that 11 plus 5 is equal to 36?
No.
No, I didn't say that. The mathematical expression did not say that it's equal. So if you do not write any sign in front of it, you know what that really means mathematically? That means that numbers are not related. In fact, if the first line could be the first line 11 plus 5 could be the money which I spend for breakfast, and then the 36, that number, the middle number, second number could be the money which I spend for lunch, and then 12 plus 22 could be the number which I spent, the money spent for dinner. And so they are not related. So in math, when you have these expressions here and you don't write anything in front of it, then that means the numbers are not related. So this is strictly speaking is not wrong. I know most of you, many of you, I should say, you write when you don't write anything, and when you don't write anything, what you mean is you mean equal, right? That's what you mean. But mathematically, that is incorrect. Sometimes you write a bunch of numbers. Let's say you want to how about this? Let's say you want to write how about the number of pages, the number of pages you read last week. Okay, then let's say the number of pages you read a number of pages of book or anything. And then let's say you want to list the number of pages last week. And then what you might do is you might say, let's say how about let's say 3, and then let's say 22, and then let's say 21, and then you might write 5, and then you write 0 here, and then 0 here, and then 0 here, and let's say, and then you know what, I'm running out of space, and then write, and then how about this, and then write 0, and then write 9, and then write 0 again. So let's say these are the number of pages you read last week. So the 7 numbers are, let's say 3, 22, 21, 5, 0, 9, and 0. So what does it mean here? Well, these are all the numbers, the number of pages I read for each day of the week, each day last week. So I read 3 pages on Monday, 22 pages on Tuesday, and 21 pages on Wednesday, and then Thursday, Friday, Saturday, Sunday. That's it. Okay? So if you do not write anything, it's not wrong, because I didn't tell you that they're the same. It's just a list. So here, if you do not write anything in front of it, no equal sign, no arrow sign, that means the numbers are not related. That's what it should mean. Okay, is that clear? So the thing is this. If you want them to mean equal, you have to put the equal sign. Otherwise, you know what, then I don't know what you're doing here. Then I will just take these numbers as if they are not related. So you either put the equal sign, or you put the arrow sign, or you don't put anything on the left-hand side. Now, if you don't put anything on the left-hand side, what does it really mean? How do I read it? I read it as if they are not related at all. The numbers, the quantities are not related. That's what it should mean. That's what it means. Okay? Although many of you, like I said, you don't put anything and then you want them to mean equal. But that is mathematically incorrect. By the way, you know what the most important sign in mathematics is? What is the most important symbol or sign in math? Almost everybody will agree it is the equal sign. When it is equal, you must write equal. Again, so the thing is this. When equal, write equal. Is that clear? When it is equal, you have to write the sign equal. Okay? So when I see a bunch of these expressions and there's no equal sign or no arrow sign, the first thing as a teacher when I grade your paper, the first thing I have to figure out is whether they are the same or not. That's the first thing I have to check. If you put the equal sign, then that will help me out. That means that you mean that they're the same thing, equal sign. Okay? So equal or arrow sign, or don't put any sign. In this class, of course, for each problem, you will either put the equal sign or the arrow sign, because we are not studying statistics. When you study statistics, you have a bunch of numbers listed and they're not related. So in that case, you don't put any sign. All right? So I just want to make it very clear. I want you to understand these symbols really well, because now you're now taking calculus. I think at this point in time, you should know how to distinguish the equal sign and the arrow sign. You must know how to write your solution properly. It is becoming more and more important here. All right? So any questions on any of these problems here? Factoring, group factoring, writing solutions. By the way, what is an equation? So let me write. I did not write what an equation is. Equation is basically this. Equation is this. So when you have an expression, so let me write expression, and then equals another expression. Then this whole thing right here, or this whole thing right here, This whole thing right here becomes an equation. That is now called an equation. See, what is an equation? Equation is basically a mathematical statement in the form expression equals the equation. We call these mathematical statements. There are many kinds of statements. Equation is only one kind. And so if you have a mathematical statement in the form expression is equal to an expression, then we call that an equation. Now the question is, what is an expression? So maybe I should define to you what an expression is. Expression is what? But basically what? Expression is what? Expression is basically is a phrase. It's a combination. It's a combined is a what? Letters and numbers, including variables. Numbers combined or connected by operations. Operations. What are operations? We mean addition, subtraction, and then multiplication, and division, exponents, and parentheses, and all of that. And then we have some other operations too. But anyway, if numbers and letters are connected by operations, namely addition, subtraction, multiplication, division, and exponents, these are what we call expression. So 2x is an expression, 2x minus 1 is an expression, and all of these, like 2x cubed minus x squared minus 8x minus plus 4. So this guy right here is an expression. Now this is expression, but this is a very this expression right here is a very special expression called a polynomial. The polynomial is a kind of an expression which has that specific form. It is a sum of terms. Polynomial is an expression, expression in the form, which is a sum of terms where every term is in this form. A number times what? Times x to a power. An integer power. Name an integer power how about natural? Let me call this natural number power. A natural number means 1, 2, 3, 4, or it's actually just a number by itself. So this is what we mean by a term. And polynomial is basically sum of many terms. But you know what? I don't think I want to go back all the way. But these are so polynomial is a very special expression which has a certain form. Again, polynomial is a sum of terms where every term is going to be like this. Okay, so anyway, you can see polynomials. This is actually what we call a term. So let me just, I don't need to put this in quotation mark. Let me just call it term. So polynomial is a sum of terms where every term is either a number times x to the natural power or a number itself. So if I give you, let's say, an example like, let's say, how about this? If I give you, let's say, give you an example, a number like, you know what? I'm running out of space here. Let me just clear this. How about this? Let me just save this and let me erase this part right here. This part right here. So if I give you, let's say, like this, for example, let's say y 1 over x. This is not a polynomial. This is what we call a rational expression. So if I give you, let's say, square root of like this, and x squared plus 1. How about if I make this guy 4, then minus x? This is not a polynomial. This is what we call a rational expression. And then when this is an expression, this is here, 4 over, and then if I give you, let's say, square root of x, and then plus 1, and then what? And then minus 3. This is not a rational expression. Now, this kind of expression, we now call this an algebraic expression. Again, this is an expression. This is an expression. That is an expression. That is an expression. This is an expression too. All of these are expressions. But this one right here, this expression in this form is called a polynomial. That's a polynomial. But these are expressions, but they are not polynomials. So polynomial is a special kind of expression. So what is an expression? Expression is basically numbers and letters combined by operations. Addition, subtraction, multiplication, division, exponent, and also includes the square root. And then all of these are called operations. The numbers and letters are combined by all kinds of expressions. That's what all kinds of operations. We call them what? Expression. By the way, addition, subtraction, multiplication, division. These four, we call them basic operations. We call them basic operations. Okay? So anyway, you know what? All of these terms are all studied in elementary algebra, so I'm not going to, elementary algebra, intermediate algebra, and so I'm not going to get into these terms here. But in math, the terms are very important because you have to understand them. But don't worry, on the test, I will not ask you about terms. I will not ask you what a polynomial is. I'm not going to ask you what a binomial is. I'm not going to ask you what an exponent is. Such things you have to know, but I'm not going to ask them. All right? Don't worry about it. But as a student of math, you have to, whenever you encounter these terms here, make sure that you understand these terms precisely. A precise understanding of everything you see or you read is very important. And I want you to understand those terms, study those terms, when you see those terms once, the first time. The game is don't study again and again and again. Always study once for all. Once for all. Once for all study so that you don't have to study them again. All right? That's the way you should study. You know, of course, sometimes you forget things and you have to study. I understand. But again, in most cases, you want to study once for all. Study until you know everything perfectly. Okay? Including all these terms. Factoring, yeah, I can spend, hours here on all these terms here. But anyway, you know what, this is calculus 1, so, I don't think I can spend too much time. It's already, we already passed that stage, right? So if you don't know what a polynomial is, then please look up. Polynomial, what is it? What do they exactly mean by polynomial? Is everything a polynomial? No. 1 over x is not a polynomial, and these are not polynomials. So if I, let's say, give you an expression like this, square root of x, this is not a polynomial. This is what we call a radical expression. But all of these are expressions. Okay, I think I've spent enough time on this. Any question on any of this stuff? Equal sign, arrow sign, and by the way, I will be looking for the arrow sign, the equal sign. If it's equal, write equal. If it's an arrow, then put arrow sign. But when you have solving an equation, then you will have an arrow sign here. That's what you have all the time. And when you have an expression-based problem, where we have an expression here, note that there's no equal sign here. The original problem has no equal sign. Then you have all these equal signs here, and these are what I call expression-based problems. Expression-based problem, and this one is equation-based. Equation meaning inequality, and some other kinds too. But inequality is also the format belongs to what? Equation. Okay, so anyway, I think that's good enough for now. I think I'm talking too much here. Okay, any questions here? Any question on any of this? No? Anybody has any questions here? Okay, no. Then I'm going to save this and let me clear this. Okay, any other questions here?
I got none.
Any questions?